Justin Richter. I'm a associate professor in sports medicine and a fellowship director as well as a vice chair for research. We see ski and snowboard injuries both quite frequently. Tearing their ACLs on the ski slopes, that's one of the most common injuries that we treat. Really, I think the breaking point is where you can safely not have an injury to the lower extremity and your equipment or gear fails first. Yes, it's monetarily you're out some money, but you don't have a severe injury to your body. We partnered with Dr. Christina Solis, who runs our biomechanics lab.
They asked if we could experimentally reproduce a particular type of injury that is believed to happen to skiers when they're downhill skiing. And that was phase 1 of this study. And then evaluate different types of ski boot bindings to see if they actually do what they're designed to do.
We are doing a study that is looking at a very specific type of injury that happens to skiers. It's called the phantom foot ski injury. And a lot of different forces are happening all at once. And the result of it is that the skier tears their ACL.
This is how it's believed to happen. There's a series of 6 events that are all happening simultaneously. Your uphill arm is backwards. The skier then begins to fall off balance towards the rear. The uphill ski is then unweighted, so the one on the back is kind of slipped out from under. All of the weight is on the inside edge of the downhill ski, so you're kind of sliding downward. The hips are below your knees, so you're really in a tight knee flexed position. And then your upper body then is facing the downhill ski. When the phantom foot injury occurs, all of these are happening simultaneously. Many ski boot bindings are designed to release in the exact same way. Your heel either comes up or your toe will turn outward. There are new bindings on the market that actually have what's called a side heel release, and theoretically that is supposed to prevent this ACL injury from occurring. The machine that we use is actually similar to machines that exist both in our mechanical engineering and our civil engineering departments. We have to design custom fixtures that attach to this machine to simulate this particular activity.
We would have a specimen inside of a ski boot, a binding in a ski. We have this upside down in our fixture. We have a torque on the femur. It's at this tight angle. We have the weight of the ski and the weight of the skier coming down. We have a tibial force that we apply, so you're kind of leaning forward, and then that final force is a quick torque like that.
When you're trying to apply very specific loads to certain bones or certain tissue types, it's actually a lot more complicated than it seems.
My hope is that within the next 6 months that we have not only identified the mechanism of injury, but been able to test all the ski bindings.
I've had a great group of people working on this project from start to now. This is just one of 22 studies we are working on. Things that we do can exponentially provide support to patients, not only at UNM, but worldwide. I think the one thing that would make our surgeons happiest is to have fewer people coming into their operating rooms during the ski season.